Welcome to the deep dive. Have you ever, bought a highly expensive fancy plant from a nursery and they hand you this terrifying list of
Oh
instructions?
yeah, like do not overwater it. Keep it at this exact
Mm.
temperature.
And the biggest one, whatever you do, do not cut it. Well, today we are unpacking a really delightful story about botanical rebellion that just throws all those rules right out the window.
We certainly are. We're unpacking this great story about two boys, Kesser and Steen.
Yeah, they basically turn a simple garden chore in Tante Gren's yard into a high-value botanical experiment. And we're also pulling from some classic forestry documentation on cultivating Japanese maples to see how they did it.
The setup here really highlights how we often get completely paralyzed by expert advice.
Yeah.
Tante Grun has these stunning 2 to 3 meter tall Japanese maples from the Acer family.
And the nursery explicitly told her never to prune them, right?
Exactly, never cut them.
Okay, let's unpack this. Because Kesser decides to completely ignore the nursery. Instead, he follows the advice of his friend Dr. Shigo from the U.S. Forest Service.
Who is basically a world champion of tree pruning.
Right, so the boys just grab your tools and start clipping away at these expensive trees.
Which turns out to be a brilliant move, actually, because Steen realizes they aren't just creating yard waste. Japanese maples are incredibly valuable.
Oh, totally.
Depending on the variety and age, even a small plant can sell for anywhere from $100 to $1,000.
That is serious hustle. So they start packing these pruned branches into their backpacks because their goal isn't just to clean up the yard. They want to make cuttings, grow brand new trees, and sell them to build birdhouses.
It's a super clever business plan, but it requires understanding the biology of what these trees actually need to survive.
Right, before they start cloning them.
Yeah.
So are these expensive trees as fragile as glass or what?
Not quite glass, but they have preferred conditions. They crave slightly acidic sandy loam, consistent moisture, and partial shade, because direct sun will literally scorch their delicate, deeply lobed leaves.
Wait, let me stop you there. Slightly acidic sandy loam sounds like total textbook jargon. Are we just talking about dirt that drains fast so the roots don't drown but still holds on to just enough moisture?
That is exactly the mechanism, yeah.
Yeah.
And that fast drainage is critical because of a really fascinating biological quirk. Japanese maples have remarkably shallow root systems.
Hold on. If these trees are growing up to 3 meters tall, how do they not just topple over in a strong wind? You'd think a massive, valuable tree would need deep, anchoring taproots.
You really would think so. It seems counterintuitive. But those shallow, spreading roots are actually what make them perfectly adapted for container growing.
Oh, really?
Yeah. They thrive in pots on patios or porches, provided you do one essential thing: you have to mulch them heavily. That layer of mulch acts as an insulating buffer against sudden dry spells and cold snaps.
Okay, so those shallow roots make them perfect for containers, which is exactly what Kesser and Steen are counting on because they aren't planting a whole tree in the ground. They are trying to grow new ones in pots from those backpack branches. So how do they actually pull that off?
Well, they consult this dusty forestry manual.
Oh, right, from the man in the green shirt at the nursery. I love that detail.
Yeah, the manual from a forestry professor.
Yeah.
And it explains that cuttings actually fall into 3 seasonal categories based on stem woodiness, like early spring to late summer.
So Kisser's actual physical process is basically like minor surgery. First, he cuts the branch just below a node.
Right, which is what the leaf pair said.
Then he carefully peels back the thin bark at the base to expose the green cambium layer underneath. He removes the lower leaves, adjusts the top ones, and plants it in a pot with soil.
Exposing that cambium layer is huge.
So peeling back the bark to hit that cambium is kind of like hitting a plant stem cell jackpot, right?
That is a great analogy. You are exposing the blank slate cells. That cambium layer is where active cell division happens and is where the new roots will physically push out into the soil. But the boys add one final, really surprising step to kickstart that division. They water the freshly potted cuttings with a special homemade tea brewed from willow-bark.
Here's where it gets really interesting, because that isn't just folk magic, you know? Willows are absolutely packed with a compound called salicylic acid.
Wait, isn't that the active ingredient in aspirin?
Yes, exactly. When you soak the maple cuttings in that willow tea, it acts like a chemical signal that shocks those exposed cambium cells into rapid division. It essentially acts as a natural rooting hormone.
It bridges the gap between old-school gardening lore and hard plant chemistry. They are chemically hacking the tree to clone itself.
It is wild. So what does this all mean for you listening? It means that with the right, fast-draining soil, a simple container, and the courage to just ignore a never prune rule, you can cultivate a high-value tree yourself.
It proves that high-level botany isn't locked behind nursery gates. The mechanisms are totally accessible if you understand how to trigger them.
Which leaves me with one final thought. If a simple homemade tea brewed from ordinary willow bark is the secret to watering and kickstarting life in these brand new cuttings, what other hidden, powerful properties might be sitting unrecognized in the ordinary weeds and trees in your own backyard?